For today's video, we'll give a very brief definition of what a blockchain is. You'll be able to explain this revolutionary technology to the people you care about at the end of the movie, rescuing them from the oppressive dictatorship that never stopped dictating your every action. So let's get started. What is a block? A block in the context of cryptocurrencies is only a collection of data. Although the data could really be almost anything, it is typically merely a collection of records. This information is essentially just a list of transactions for Bitcoin, the most particular cryptocurrency. As an illustration, it might read as follows: X pays Y $50, A pays B $80, and Y pays H $15. With Ethereum, it's typically just transactions, but there are a few more possibilities, such as so-called smart contracts. Some alternative coins might be the use of data, papers, or Wi-Fi. Nevertheless, a block is nothing more than a group of records. You should be aware that blocks do have restricted and can only contain a certain number of transactions, which is why we must continually create new blocks. In the case of our example, there are currently 1,500 transactions on average for every block in the Bitcoin network. This figure is currently fluctuating, but you don't really need to know why. Just be aware that these blocks do eventually fill up, at which point we must do action. When these blocks are full, we simply add them to the network. You may now be wondering how we go about doing that. We do a process known as mine them. And because Bitcoin uses a proof of work algorithm, we must demonstrate that we are aware of them. This brings up the concept of a hash. What is a hashing function? A hashing function is a device that accepts inputs and procedures a hash in response. Inside this mysterious black box, there's a ton of math going on. However, in essence, you give it something, and it delivers it to you in return. Bitcoin, in this instance, uses the SHA-256 hashing algorithm. The number 256 denotes the number of zeros and ones that the secure hashing algorithm SHA uses to generate its output. Therefore, it will always output 256 zeros and ones, whether you enter your name or the complete dictionary. Since modern computers are now intelligent, they convert these zeros and ones into letters and numbers. This sophisticated procedure may merit its own film. But in order to use hashing functions, you primarily need to be aware of three things. Number 1, you can't find the input of a hash. You have to guess and check. In this case, an A, you will receive D. Then it will give you J if you give it double A. And after that, if you give it triple A, you'll get U. Imagine that you have to keep adding A's until you discovered what caused you to receive an F. Number 2, changing the input just a tiny bit changes the output a lot. The second thing you should know about hashing functions is that even a small modification in the input can have a significant impact on the final result. In essence, you get this as the output if you SHA-256 this and subscribe to our channel. But even though we added one word, if you do, kindly subscribe to our channel so you can see how drastically different these are. Number 3, calculating the hash takes some time. The hash calculation takes time, which is the third thing you should be aware of, even though it might only take a few moments to process a single little string of text. The time and processing resources required to process a full book or a million different permutations of it quickly add up. Therefore, whenever you mine Bitcoin, you're trying to add random numbers to the block in order to get a unique finish. You will receive this as the result. For instance, if we were trying to mine this and X pays Y $50, A pays B $50, and Y pays H $15, what number do we need to put at the end of that list to get a zero at the end of the hash? As this is what Bitcoin is doing right now. Using my small Python program, we can calculate that it requires 3 checks to reach the first one, which is reached when you add a 2 to the end of it. If we start with 0, check it with 1, check it with 2, and so on. After executing my little Python program, we can see that it takes 438 tries until you get the first hash that finishes with 0, 0. Decentralized. The next aspect of a blockchain to be aware of is that it is decentralized. Now consider it this way. It doesn't have to be too confusing. Centralized implies that only one person is in charge. For instance, only your instructor could add or change your grades in high school. If they didn't like you, they could flunk you. This isn't personal. Perhaps you simply didn't grasp what they were teaching since they were bad teachers. Decentralized, on the other hand, refers to the ability of multiple people to view and modify your grades. Imagine if all your classmates were permitted to view the test answers and grade you based on your assignments and exams. Imagine if someone other than your teacher could decide your grade. Decentralized implies essentially at this point. Anyone who wants to can physically have a look at a list of all the Bitcoin transactions, which is better than just one person having this information. And this is the key point. Anyone can mine the blockchain and cast a vote, so they can claim that Bill really did send John $50, or that they created a phony transaction and claim that John gave Bill all of his money. Therefore, you might be wondering how you can ensure that no one uses my money for a fictitious transaction. The use of asymmetric encryption with cryptocurrency wallets fixes that issue. But going back to the definition of decentralization, why would a bunch of kids want to peek at your papers and test? Furthermore, why would they want to spend so much time studying them before grading the exams? Well, they would be compensated too in this analogy. You virtually always receive a benefit for participating and casting wise votes on blockchains. For example, you are compensated in Bitcoin for mining Bitcoin. We've already discussed how a block is simply a collection of data. A hashing function's purpose is to ensure that participants in the blockchain put forth the effort. Decentralization, which we discussed, fundamentally entails that it is not under the control of one individual. The chain. Let's explore the meaning of the term blockchain as it relates to Bitcoin. There are 2 other things you should be aware of. 1. This is how more Bitcoins are essentially created. Whoever cracks the block and discover the magical hash with as many zeros we're looking for, they add Y board, crypto's account, receive 2 Bitcoins for mining at the top of the block. This is their mining reward. However, as time passes, that number 2 decreases and becomes smaller. Secondly, you must be aware that they additionally add the most recent block's hash. The last block's password is therefore added to this one, and the hash of that block is actually used to determine the hash of this block. Thus, it becomes a chain, since each block references to the one before it. This is how the blockchain's magic operates. The newer blocks all change if you attempt to update an older block because you messed up the hash that it referenced to. Remember how we discussed the hashing algorithm and SHA-256? We can prevent someone from going back and adding additional money to their account in an old block if they change something just a little bit, because doing so changes the entire thing. Because the blockchain cannot be modified, anything that is contributed to it is effectively recorded in history for all time. Although this is problematic for things like copyrighted content or embarrassing things, it is the essence of the internet. Thus, it is actually quite helpful for things like transactions. In conclusion, blocks are made up of data, typically a list of transactions in the case of cryptocurrencies. After we have a block, the next step is to determine its password, or more specifically, what is the hash that solves it. Miners do this by guessing and checking until they succeed. Once they have solved that block, they check to see that it is connected to the previous block. As a result, because each block references a previous block, each block truly contains the history of every transactions. A blockchain is a chain because each block is linked to one before it. This is what makes it a chain. From our discussion, what have you learned? Please let me know by leaving a comment below. And if you enjoy this video, please press the like button, turn on the notification bell, and subscribe to our channel for more videos like this. Thank you for stopping by to watch. See you in our next video.